Greetings everyone. Myself Atir Nasir. I am a PhD student at Department of Electrical Engineering, IIT Kanpur, and I will be hosting the doubt clearing and assignment solving sessions for the course Semiconductor Devices and Circuits. The course will be taught by Professor Sanjeev Sambadhan, and I will be mostly solving the assignment questions during the course. So let me go through the course layout first. This is broadly the what will be taught during these 12 weeks, and you can see that as already the week 1 has been published, and you can go through the material of week 1, and the professor has gone through the broad aspects in the quantum mechanics, and then uh, it will be oriented towards the solid state device physics, and at last we will be seeing some novel thin film transistors in the course. And there, let me start with some brief history about the transistors. So it was in 1947, the first point contact transistor was shown, and it was not the silicon device that was shown to be the material for this point contact transistor, but it was germanium. And the two gentlemen who showed us this were this device, this point contact transistor, were the Bardeen and Bretin. And these two gentlemen showed the first point contact transistor, and it was around the same time that Shockley came up with the theory of p-n junctions. So uh, after this there was some drastic improvement, and the metal oxide semiconductor field effect transistors came to be known, but there were some uh, constraints to it because of the fabrication bottlenecks. So in 1960, these two gentlemen, Atla and Kang, they showed the working of the MOSFET, and it was fabricated, and it was somehow a defect-free MOSFET as compared to the previously fabricated devices. So these MOSFETs, they have some advantages over the bipolar junction transistors, and they today cover almost 95% of the market as compared to the bipolar junction transistors. These main advantages are the low power dissipation and the higher packing density, because this enables us to reduce the cost of the circuitry that we are going to design. So this was some brief history about the devices, how the first device was based on germanium and not the silicon. So let us see some of the differences between these two silicon and germanium based devices, because currently, as we know, the market is dominated by the silicon based devices, not the germanium based devices. So let me ask you some of the trivial questions. What is the band gap of silicon? So the band gap of silicon is 1.12 electron volts. So there are uh, uh, experimental methods that can be used to obtain the band gap of materials, and there are also the first principle methods that can help us to get the band gap of the materials. These first principle methods are can be used to get the material band gaps, and we can see that this silicon here has 1.12 electron volt band gap, so this option C seems to be correct. And for germanium, if I ask you the same question, and it is seen that the germanium has band gap of about 0.67 electron volt. So this germanium has a band gap of 0.67 electron volt. So basically, this silicon is having much higher band gap as compared to the germanium. So let me ask you another question in this way: which has more leakage current, whether it is silicon or germanium, or other way, which is capable of handling higher temperature so that we can use it for high temperature applications? And the answer to this question is simple, and it is silicon. Because as we have seen previously, and we will be going through this in the course as well, when we will see the intrinsic carrier concentration dependence of the material, we will see that there is dependence of the band gap. The band gap decides the intrinsic carrier concentration that a material can have, and we can easily confer from there that the leakage current this leakage current will be more in less band gap materials. So these silicon based devices will be having less leakage current. So the silicon is capable of handling high high temperatures as as compared to germanium based devices. And now the answer to the first question will be, which has more leakage current? The answer will be clearly germanium based devices will have has more leakage currents. So we can see clearly that there are disadvantages of germanium to be used as the channel material. That's why we didn't use it in further devices after its demonstration by the two gentlemen in the 1947. We moved to the silicon devices. So let's see some of the advantages of these silicon based devices. The first and foremost advantage of the silicon device is its cost. Because it's available readily in nature, the devices based on the silicon are cheap. So the it takes the most important most important factor, that is the cost. The devices based on the silicon are cheap, and also the silicon has unique capability that nature has provided silicon with this native oxide, which is easily grown uh, on this silicon, and by the process of like thermal oxidations, and will this Si2 will provide uh, excellent electrical and mechanical properties, and this SiO2 has some good amount of breakdown strength as well, which is of the order of 10 to the power 7 10 to the power 7 volt per centimeter. So this SiO2 is also this native silicon oxide, as we will see in the devices as we move, that oxide is what we will be uh, needing between the channel and the gate. And this oxide its fabrication, or how it is how easy it is to grow oxide on a device will largely determine its applicability in the market. So this SiO2 can easily form on the silicon devices. So this is also the major advantage of the this silicon device. And as already discussed, the silicon based devices, they have large band gap, or we can say in practice they have moderate band gap, but as compared to the germanium, we can say it almost has its two times band gap. So the leakage current in the silicon based devices is less as compared to the germanium based devices. This helps them to withstand the high temperature applications as well. So, uh, thank you for listening to this week zero basic introduction, and we will be having our regular assignment solving sessions on Sundays. It will be from 5 to 6 in the evening. See you in those live sessions, and you are always welcome to ask the questions. Thank you very much.